Alright, reading 14, supply, demand and supply analysis with a focus on consumer demand. We are going to cover this entire reading today, and the agenda is as follows. We will first talk about consumer theory, then utility theory, the relationship between utility theory and indifference curves, the gains from voluntary exchange. I have this italicized because this is part of the reading, but it's not a learning objective statement for this chapter. So I will explain it briefly. Those who will follow Schweser will notice that even though you see this in the curriculum, it's probably not going to be in Schweser. I have not seen Schweser yet, but nevertheless I think it's useful to know this material, so I'll spend 2 minutes and then you will find this useful in subsequent reading. So I'm just following the flow of the curriculum. Then we'll talk about budget constraints, production and investment opportunity sets. Again, this is not a LOS, but very important stuff to know. Determining consumers' equilibrium bundle of goods, consumer response to changes in income and price, substitution and income effects, normal and inferior goods, Giffen goods, and Veblen goods, which most people probably have not heard of to date, but that will change today. Okay, let's first talk about the consumer theory. All you really need to know at this level is what is consumer theory. So consumer theory fundamentally relates consumer demand curves to consumer preferences and constraints. So the idea is straightforward. Different consumers have different preferences. There are different rates at which different people are willing to trade off between goods. So that's one point. Another point is that consumers have budgets. So when you combine all these things together, consumer budgets, what consumers like, what they don't like, what their other constraints are, all these collectively influence consumer demand. Okay, so this whole theory that we are going to talk about is going to be a elaborate derivation of the consumer demand curve. Earlier we talked about the fact that demand curve is downward sloping, but why is it downward sloping? Today we are going to get into the depth of that. In other words, what we are going to look at is things that consumers like to do. So most consumers would like more and more of everything. So you combine what consumers like with what consumers can do, constraints coming from your salary. You would like to have, let's say, more and more good stuff, but what are you constrained by? By your income. So the income essentially defines what you can do. You combine the two and that determines what you do, what you actually do. Okay, so that is a high level executive summary of what you are going to see today. So let's now talk about the utility theory, where we will create models for consumer preferences and tastes. These, by the way, 3.1, these are simply the sections in the curriculum, so you can, those who like to read the curriculum or see the curriculum can follow along. What I am effectively doing in these lectures is going through the whole curriculum, and rather than having you read 80 pages, for every section I am picking out the essence of that section. So you can sort of, those who read study guides can also feel that you've gotten a decent flavor of the curriculum. Okay, when we talk about consumer theory, first we should understand the axioms of consumer theory. How many people know what an axiom is? Given right here, axiom is simply an assumption which is assumed to be true. So in order to build theories, you need to make certain assumptions. So if we are developing this or understanding the consumer choice theory, we should first understand what are these assumptions which must hold true to understand or to come up with this theory. Before I explicitly talk about the three assumptions, let's just make sure we understand what a consumption bundle is. A consumption bundle or consumption basket, those two terms are synonymous and will be used interchangeably. So a consumption bundle or basket is simply a combination of goods and services a consumer would like to consume. Now you might have a bundle A and a bundle B. So bundle A very simplistically has milk and bread. Let's say this bundle has 2 cups of milk and 4 slices of bread. You can have another bundle that is made up of soda and donuts or whatever. So obviously different items would constitute different bundles. What is not so obvious and should be made clear here, even the same items, milk and bread, but different quantities would constitute a different bundle. Okay, so that's the definition of a bundle. So one bundle means X, Y, Z goods, so some specific goods in specific quantities. Okay, so that's the definition of a bundle or a basket. Next, let's understand the three assumptions. The first assumption is that of completeness. This assumption says that given a choice between two bundles, a consumer will very clearly say that I prefer A, or I prefer B, or I am indifferent. He can't give a vague answer that let's say your two bundles are, let's say you have a bundle X which is tea and samosa, 1 cup of tea and 1 samosa, and your bundle Y which is your coffee plus a donut. Okay, so a consumer needs to be very clear. I either prefer this or I prefer that, or I'm indifferent. You can't say that in the morning I prefer my coffee and donut and after lunch I prefer tea and samosa. So you can't give a vague answer. So you need to give a complete, crisp, solid answer. I prefer this, or I prefer that, or I'm indifferent between X and Y. So that is the assumption of completeness. Okay. Next is the assumption of transitivity, which means that let's say you have three bundles A, B and C. If a consumer prefers A over B and B over C, then he must prefer A over C. Okay, so that is the assumption of transitivity. In the real world, you might have a situation where A is preferred over B, B is preferred over C, but for some strange reason C is preferred over A. In this theory, we can't do that. Okay, so this is the assumption of transitivity. And 3 is the assumption of non-satiation, which means that you are never satisfied, in the sense that for a given bundle, like let's say your bundle is just milk, even though you've had 50 cups of milk, the 51st cup of milk you would still want. You might not want as much, but you would still want it. So you are never satiated. More is always better. We are not saying that it is much better, it might just be marginally better, but more is better. Okay, so that is the assumption of non-satiation. You need to memorize these three: completeness, transitivity, non-satiation, and memorize what they mean. Okay. Okay, next in section 3.2 we talk about representing the preference of the consumer through what's called a utility function. So a utility function measures the happiness level or the utility that a consumer derives from a given basket. And mathematically, the utility is a function of the different items and the quantity of those items. So very simplistically put, again, let's say that our basket is milk and bread. Now just as a side remark, the curriculum keeps on using wine and bread, but I just made this culturally more appropriate and more wholesome. So throughout this lecture, I'll say milk and bread. Okay, so we have a basket that consists of milk and bread. You might just have a function which says that the utility that a consumer derives from milk and bread is equal to the number of cups of milk multiplied by the number of slices of bread. Just making up a simple function. There might be another function. So in other words, if a consumer gets 2 cups of milk and 4 slices of bread, then his utility is 8 utils. So there is a way of coming up with how happy the consumer is with a given basket that has these 2 items in this quantity. An important point to note about utility and utility functions is that it's based on an ordinal scale. We will see this later in quant. Ordinal scale means that if you have 2 baskets, one basket gives you a utility of 8 utils, another basket gives you a utility of 9 utils. you can say that in terms of order, this is better than, so the basket that's giving you 9 utils worth of happiness is better than the basket which is giving you 8 utils worth of happiness, but you can't say how much happier you are. So just because there is a third basket that gives you 10 utils, you can say that this is better than the basket that gives you 9, which is better than the basket which gives you 8, but you can't say that the difference between, let's say that this is basket A, this is B and C. You can't say that the difference between B and C is the same as the difference between C and B. So when we talk about ordinal, we mean that you can order these, but you can't state that the difference between two items is constant, or that doesn't have any meaning. So in an ordinal scale, you can say this guy is better than that guy, who's better than that guy, but you can't say how much better. We'll see this again in quant. This is called an ordinal scale. Where does this ordinal word come from? Simply from ordering. The difference does not have a meaning. Versus, this is just a side remark, a cardinal scale is a scale where the difference has a meaning. So when you talk about degrees centigrade, for example, 12 degrees centigrade is 1 degree more than 11. 13 degrees centigrade is 1 degree more than 12. So the difference makes sense. So that is an example of a cardinal scale. When we talk about utils and utility preferences, etc., we are referring to a ordinal scale. Okay. Next, let's talk about indifference curves. Indifference curves are simply a graphical representation of the utility function. And you can get used to this, just like in the earlier reading you saw that we had a demand function, and then a graphical representation of the demand function was the demand curve. Supply function graphically represented by the supply curve. Utility function is graphically represented by indifference curves. So first I'll make a general point about indifference curves and then talk about these indifference curves. So on the x-axis you have quantity of bread, on the y-axis you have quantity of milk. Let's say that you are at this point here, which is, let's say, 4 slices of bread and 2 cups of milk. Now this is one bundle. Can you agree with the fact that everything in this range will be, so if this is bundle A, any bundle over here would be better. Why? Because given our 3 assumptions, so given the assumption of non-satiation, for example, if you have 2 cups of milk and 4 slices of bread, what does this point represent? 2 cups of milk and 5 slices of bread. Would that not be better than A?
Yes.
So that means anything along this line is better than A. Similarly, anything on this line where you have 4 slices of bread and say 3 cups of milk, so that would be better. We are not saying how much better, we are simply saying better. So anything on this vertical line is better than bundle A. Anything here is better than bundle A. So essentially anything in this whole region is, any bundle over here is better than A. Agreed? So then what about this box over here? So in this box, any bundle here would be inferior to bundle A. Agreed? What about bundles that fall, say, here or here? It's hard to say, we don't know. Okay, because this bundle depends on how much you love milk and how much you love bread. Okay, and that's what we are going to get into. So notice these indifference curves. So you can say potentially that along this curve you are indifferent between milk, you are indifferent in the sense that you are when we say indifferent, we mean that you are just as happy anywhere along this curve. So if you are initially at 4 slices of bread and 2 cups of milk, then you can be equally happy, for example, if you have 5 slices of bread and say 1.5 cups of milk. Okay, so this might vary from person to person depending on how much you like milk and how much you like bread, but conceivably, or for anybody, this will be a negatively sloped curve, and depending on your preference, the curvature or the convexity. Does everybody know what convexity is? So if you are sitting here and looking from the origin, so just a quick point, so looking from the origin, this is a convex curve. So in general these curves will be convex. Why? Because once you have a lot of bread, the additional utility that you will derive from one more slice of bread would not be very much. So you would be willing to give up a lot of bread over here for a little bit of milk. Similarly, here you'll be willing to give up a lot of milk for a little bit of bread. So that's why these indifference curves are always or almost always convex. Okay, now these are different indifference curves. Again, just to highlight, on a given indifference curve, you are indifferent in the sense that you are equally happy at point A versus point B. But what about different indifference curves? Are you happier as you move this way? You are obviously happier as you move this way, because if you just compare this point X with point Y, at Y you have more milk and more bread, therefore you are happier. Okay, so from if everything were in your control, you would be be way to the right. Okay, so this is indifference curves. You've understood that indifference curves represent the utility function. What is the marginal rate of substitution? So
do the utility functions change from one indifference curve to another?
Yeah, so the utility function, so it would be the function would be the same for a given user, but each one of these would represent different points, would represent different baskets. So when we do a few examples, it will become more clear. Okay, so marginal rate of substitution between, let's say, bread and milk. What this means is, let's say that the marginal rate of substitution is 2. What this means is the rate at which you are willing to substitute milk for bread or vice versa. Now, the way this convention is used, the first item or the first subscript here, it's always 1 unit of that. So this means if the marginal rate of substitution bread milk is equal to 2, that means you are willing to give up 1 slice of bread for 2 cups of milk. Okay. Now, will the marginal rate of substitution be the same anywhere on a given utility curve or an indifference curve, or does it change? It changes, because so if this is milk on the y-axis, bread on the x-axis, so for 1 unit of bread over here, when you don't have much bread, for 1 unit of bread you would require, to give up 1 unit of bread, you would require a lot of milk. So is the marginal rate of substitution high over here? Yeah, so the marginal rate of substitution is high. What about over here on the same indifference curve? Now the marginal rate of substitution would be low, because for 1 unit of bread, to give up 1 unit of bread, you would be happy with just a small amount of milk. Okay, so you understand hopefully this point, and we'll do an example on this. Next, indifference curves cannot cross. Hopefully that's obvious, because that would then violate some of our earlier assumptions. So on a given indifference curve, you are equally happy. You are indifferent between any bundle along a indifference curve, and as we move right, we are happier. So this way, just to make it explicit, so this way we are happier, and as we move this way, we are sad. Okay, so that should be obvious. If you found this clip interesting and informative, please visit my website www.arifirfanullah.com. Here you will find a tremendous amount of useful material. Right here in the 2011 CFA video lecture series, you will find the entire level 1 curriculum for free, and most of the material here is still relevant. So this is worth looking at. The 2012 video lecture series covers both level 1 and level 2. These lectures are available for a fee. And finally, down here, financial management at IBA. Here you will find my lectures at IBA for a course on financial management. Plus, you'll find lots of useful spreadsheets that can help you with financial modeling. So again, please visit www.arifirfanullah.com. Thank you.